Okay, guys, new talk, creating a great red team tool by me and David. So who am I? I'm Will Dandrade. I'm the head of research from New Jersey, the best state in the world. I'm a second-year cybersecurity BSMS. Why are you guys laughing? New Jersey's a great place. Red team and offensive security focused. I'm a huge cooking, culinary, hockey, baking, coffee, hiking enthusiast. I'm a radical hummus lover, and I spend roughly 25% of my income in 2024 on coffee brewing equipment.
Yes. I'm David. I used to have a really cool Who Am I? I lost it. I do infrastructure engineering automation. I'm a treasurer for RITSEC, big swag surfer. Bunch of photos of my dog up here. He's pretty awesome. Bottom left, my photography arc that lasted like 5 days. And then, yeah, me and Michael Scows, the taco hats, my girlfriend Emma, and me and David Munson. And that's basically all that I am.
Beautiful. So joining Red Team. In order to be on Red Team, you're going to need 2 Blue Team competitions, which is the easy part. That's straightforward. You sign up, you go. But the part that's a little more abstract is creating a Red Team tool. Because what do you do? How do you do it? It's a little bit intimidating. So while making a tool, it's going to require a little bit of programming experience and some offensive security thinking. So Red Team tools. So a Red Team tool can be anything that advances Red Team's goals. This is very broad, so Red Team is just generally focused on the spirit of competition and creating a fun educational experience for Blue Team members. And that kind of means that we're going to be doing a lot of denial of service, and this means that things are kind of primarily focus on persistence and data collection. And also, don't be too mean. I got people coming to me, hey, can I just like turn off people's keyboards? Like, no, you got to be nice. You got to be in the spirit of competition, things like that. So as for brainstorming, a good thing to do is ask the Red Team chief, other people in Red Team. A lot of people are going to have tool ideas that they've kind of thought about or just even like considered in their head very slightly, and they might be cool to actually flesh out and look into more. For broad tool ideas, you got the MITRE ATT&CK framework, which is going to show you kind of the categories of tools that you can make. The main ones we're going to focus on persistence and data collection. Windows is also generally less focused on in the Red Team at RITSEC, so there's a lot more potential for tools there because Linux is much more saturated. And if you have a meaningful, also you can meaningfully contribute to existing tools, and that can also happen in place of that as well. The idea of making a tool is going to seem a bit overwhelming, but you should just commit to an idea and start to flesh it out. And I think plenty of people in club would be willing to help you if you run into issues. So for lower level languages, these are kind of the ones that most people are going to suggest, C++, C, and Rust. They're the most commonly mentioned languages when it comes to malware development. And why? This is because they're low level, they allow you to manipulate memory, has minimal dependencies, and produces small binaries that run efficiently. And while the binaries and capabilities of these languages are great, the development process suffers if you're unfamiliar. Managing memory, pointers, and other aspects of low-level languages is significantly complex when you're used to Java or Python or any of the other required curriculum languages. Even though you should learn low-level languages at some point, they're not a strict requirement when you're making a Red Team tool, and that's kind of what I'm trying to show here today, is that the barrier to entry for these things is not quite as high as you think. Even if you only did the basic requirements for the cybersecurity degree, you can still make a Red Team tool. And if you're pivoting from a system administrator background or a software development experience, you can still make a Red Team tool. So one thing we're going to focus on here is increasing accessibility to Red Team tooling using higher level languages. You can essentially use any language to create a tool, and here are some worth checking out. You got Java, and using GraalVM, you can make standalone binaries. C#, if you configure it correctly, will make standalone binaries. Python can make standalone binaries. And then we have some interesting alternatives to low-level languages, what you could call quote-unquote exotic languages, like Dlang, Nim, and Golang. So for Java, maybe you've only done the required coursework. You did GCIS 123, 124, or 127, and you know Java. You can still make a tool. Java is a language that normally requires the Java runtime environment, which is the JVM. And that needs to be installed on the host machine, which is obviously going to really mess up your deployment if it has that sort of dependency. But fear not, because Oracle has a more advanced version of the OpenJDK called Oracle GraalVM, which is an open source project that includes a native image utility that will allow you to compile Java into a single native binaries with no external dependencies. You don't even need the Java runtime environment installed on the computer. So when it comes to about GraalVM, it's a product of Oracle, and it works with all the same libraries as in OpenJDK. It's a more advanced Java development kit, and it supports making a standalone binary. And it creates much faster Java code as a result, and it optimizes significantly and only uses the parts of the JRE that it needs to reduce the size of the binary. It also resolves pretty much all the issues that you would have trying to use Java as a red team tool. Another good choice, especially for Windows, is C#. C# has an extensive number of Windows libraries, which makes it great for interacting with the Windows system. And as of .NET 0.5 and later, you can compile C# into single self-contained executables. If you already know C# and you need to make a Windows tool, this is a great option. And all you need to do is in your project file, the .csproj file, you just need to specify that's self-contained and it's a published single file for the configuration of the compile. Python, you can also make binaries with Python. All you need is PyInstaller, as Drew alluded to earlier. That was his first tool. PyInstaller basically just bundles the script and any other supporting files to make a self-contained executable. You can just run PyInstaller, one file, no console, your script.py, and it'll just make a .exe. You can also specify payloads or JSON files that can be packaged with the .add data flag. Getting into the more novel languages here, we got Nim. Nim was released in 2019, has gained some sort of popularity among malware developers. It kind of aims to combine the productivity of Python with the portability, compatibility, and performance of C. The Windows library gives it very easy access to the Windows API, which makes it suitable for Windows tools. And like most of these novel languages I'm mentioning, it's not very well detected by AV just because it's not very highly used. Using Nim, as you can see, it has an interesting syntax. It's closer to Python, even though it is capable of doing lower level language. It's compiled to C, C++, or JavaScript, which is really funny because those don't seem, it's just at all related. But Nim can be used with or without a garbage collector. And if you don't know, a garbage collector is basically automatic memory management, ensures optimal memory management and memory safety. Nim allows full access to memory as well if you want. It's something you can kind of turn on or off. And it's a small, kind of poorly marketed language. It hasn't gained significant traction in the industry, but it's a good option if you're just looking to kind of get into doing some malware development or for a personal project. Another option is delaying. It compiles to native machine code like C or C++, and it allows for automatic and manual memory management. It's very similar to Nim in concept, but with some differences. Most people are considering it more feature-rich than Nim, and I think it's a little bit cooler. The syntax is much more like C, and it would be a lot more intuitive to someone who's coming from C. And it essentially combines the benefits of C with memory safety and high-level features like built-in string manipulation, hash maps, etc. It can also operate interoperably with C code, so you can just put it into existing C projects and it would work. It also has compile time reflection, so it's possible to generate code based on the types, functions, or properties of the code currently being compiled, which has some obfuscation applications. It's also suitable for Windows malware, as it can also use the Windows API. And it's a great option for someone who knows C and wants to write code a little bit faster and easier using these higher level features and memory safety.
Golan's pretty awesome. It was designed for kind of networking and interfacing with multi-core systems and multi-threading. The goal behind Go was to be statically typed with the runtime efficiency of C, which like C is still faster, obviously, but with Golang, you get a lot more robust networking and packaging. Generally, you see it with like command line tools, cloud and server application, DevOps in general. If you've written a Discord bot, you might have written it with Golang. And in our case, it's really, really good for making a C2 because you can very quickly make an application that can take a lot of endpoints and manage them all really efficiently. It's really easy also to make command line tools for system administration. I mean, this is from my C2. It took like a couple hours maybe to make the entire thing. And it was really easy to get it running with a terminal UI. And it's very fast. Other problems I've never had problems with like dozens or even hundreds of clients connecting. And honestly, if you know Python and C, you can learn enough Go very fast to make whatever red team tool you want. And it's just kind of pretty awesome overall. It's really easy to make into a single file. You just run go build and it packages your entire system. And yeah, it's just like pretty awesome. The binaries can be compiled for Linux or Windows, and it's not really much harder to compile it for Windows. So it's a really good option for making like implants and things like that that need to network and communicate.
So when you're using these languages, are still some when you're using these languages, there's still some drawbacks. They often have less robust libraries and documentation. I think we've probably all had an experience where we're doing something like weirdly specific and Python just had like a super robust library for it for some reason. And there's also less chance of support after graduation. A lot of these languages are pretty impressive, but they're just not popular among RITSEC students. And while they're great for personal projects, companies don't use these languages and they won't do quite as much for your resume as if you put C on there. But the purpose is that these languages are a great way to ease into low-level and malware development concepts, and getting experience with these malware development concepts and low-level programming is important and can help be applied to anything you do in the future.
Another thing is testing is like critical if you want to make an actually useful tool. Like it's really a big pain to write tests for your code. We all remember GSys 124, 123, and it can really feel like a waste of time. But if you have written out test cases for your system, especially if it's being written in Go or Python or Java, something that really natively supports testing, you can save yourself a lot of headache. And if you combine that with incremental development, you can have a tool that actually like works most of the time, and that is not as easy to do as it sounds if you just make your tool and go for it and get it working in one test environment on one operating system in one virtualization software. So if you actually test your code and you write tests and you actually try like you'll usually have the infrastructure for competitions a little bit early if you ask for it, and you can see what services will be there. And if you actually test your tool on an example of comp infrastructure, you can run into the problems that you'll meet during deploy a lot faster, and you can save yourself a lot of time and headaches and staying in the club room until 3 a.m. on deploy night because your binary is not working and you can't find it and everything's falling apart. So make sure you test what you make, and if you can and you want to be a really good developer, make sure you write tests to automate the testing of your software as you go.
Yeah, so a good way to get into testing is to get your DigitalOcean $200 using GitHub Student Pack. Basically, if you scan this QR code, you can visit the page and verify your student email with GitHub. If you don't have your RIT email connected to your main GitHub account, you can just go in and add an email. And then all you need to do from there is go to SIS, go to academic records, and go to enrollment verification. You'll get a little PDF. You're going to have to convert it to a JPEG or a PNG. But once you do that, you can upload it to GitHub. GitHub will verify you. It might take an hour, it might take a week. It's kind of unclear how it works. But then you can connect DigitalOcean to GitHub, and you'll get $200 towards your cloud test environment, which is pretty awesome for testing red team tools.
Yeah. And the reason that DigitalOcean is cool because you can also get student packs for Azure and AWS and GCP, but DigitalOcean is really cool because it does not have a lot of overhead. When you go in, it's very quick turnaround between I want to make a virtual machine. All right, they're called droplets, right? And you go to make a droplet, and you'll have an option of what size do you want, how much do you want to pay each month, how many do you want to create, and it's very easy to do by hand and very intuitive, which is really good if the only thing you want to do is just test your tool in an environment that also has a public IP in case you want to test callbacks. But you don't have to stop there. It's really easy to automate your tool being deployed with Terraform. Terraform will get your droplet and virtual machine up. And then what we're going to talk about, Ansible, shortly, that can be used in pair with Terraform on DigitalOcean to automate the entire process of deploying your tool in case you need to make a test environment to see if the new update you just pushed to your package is actually going to work. The one thing is if you want more than a couple of droplets, you do have to submit a request with DigitalOcean. But when I submit my request, there was an option to say it was educational, and I have a feeling that they don't really read those requests if they're below a certain point, because I got approved, and it felt like actually 35 seconds. Like I refreshed my email, and they were like, "Yep, sure, have a good time." Yeah, I have a photo. This is what it looks like to make them by hand. You literally just click, okay, I want a basic droplet. Okay, I want a regular type of CPU, and I want 1 gigabyte of RAM and 1 vCPU, and boom, it's $6 a month. And that's all you have to do. You click create, which is not in the screenshot, but it's a big blue button. It's very comforting. And you create your droplet. It gets a public IP. and you can start testing like right away. It's very easy to add your SSH key, and it's just very beginner friendly. Sometimes with Azure, you're getting caught up in like, all right, I need to make the virtual machine, and I need to make the public IP instance, and I need to attach it to my network. And if you're working with AWS and it's your first time, AWS user interface is really scary. Same story with Google Cloud Compute. So it's really just easy to get started with DigitalOcean.
Yeah, I don't want you guys to overlook development. With my first tool, I knew how to code. I had a great working tool on my test VM, but I did not know how to deploy, and deploying didn't go too well. You want to avoid party deploying, car deploying, plane deploying, or just in general deploying until 3 a.m. Yes, all of those deploying situations have happened. And Ansible, it may not work as intended on the first try. You're going to look at it, you're going to be like, oh, this is perfect. This is exactly what I need. And then everything on Windows explodes, and then you got to go back to the drawing board. So basically, you're going to want to test a lot, and you're going to put a lot of thought into the deployment process.
Yeah, so a cool tool that doesn't deploy is useless, right? I mean, it doesn't matter how much you can do in your test environment because you need it in the comp environment. On the other hand, a mediocre tool that always works and deploys correctly is really awesome, because you can actually just like use it. The most important thing really is getting a tool that actually works. And in order to do that, Ansible and shell scripting are very, very important to be familiar with, or if you're working on Windows batch scripting. An easy way to get used to Ansible and shell scripting is to test deploying your tool at each stage. So for my C2, I tested with a web server. Then I tested with one connection. Then I tested with getting multiple connections. And instead of trying to do the entire thing at once with what I wanted my end product to be, I went slowly at each stage and wrote down what packages I would need from Ansible, what systems configurations I would need, and I actually just tested it. So make sure that as you go, and you're trying to automate the deployment of your tool, which should always be your end goal, because you're not going to be able to deploy it by hand to every single machine. Make sure that you're actually keeping track of what you're doing, and make sure you test it. And shell is really cool because you can use it not only in Ansible, you can deploy shell scripts onto your hosts, but you can also run Ansible commands with shell scripts in case you want to do something where you have like, okay, deploy to all of the Team 6 boxes. You can write a shell script that gets all of the Ansible commands you want, and then also any callbacks you want from the output of Ansible. And it can just really be cool, and it can work really, really well to deploy your tool. So if you want to streamline and automate the process of deploying your tool, you're basically going to have to use Ansible. If you look in this bottom right corner, this little GIF here is my entire tool deploying. What Ansible does is it's a software that connects using SSH keys to remote machines. You put in what's called an inventory file, which is basically just a list of IP addresses and aliases for those IPs. Like for my tool, I have an inventory file that says, here's all of the node public IPs. And then I can go and run my Ansible onto my nodes. And then I have a management inventory file that says, here's my management box. And that's kind of how you split up who you send your Ansible to. The way that you actually like set up your Ansible file is you're gonna have a bunch of main files that run what's called roles. Roles are just a breakdown where you have, for example, if you look at the manager, you have tasks and templates and sometimes other folders, but those are kind of the two big ones. Tasks are things that actually run on your Ansible, and yeah, I have some right here. So I have like, here's my management box Ansible. Essentially, it clones the binary of my C2 manager. It makes it available in the home directory and the bin of the remote machine. It clones my systemd service file into the remote machine, and then it starts it. If you look in the bottom left, you can see kind of the more big picture on this left-hand side. Those are the main files I talked about that aren't inside of the role, where all you do is run the roles that you've already configured, and it can be really quick to make different configurations. Like this bottom left one does my manager and nodes instead of just my manager. So it can get really complicated, your Ansible, but if you write it incrementally and you write it step by step as you're actually producing your tool, all of a sudden you'll realize pretty deep in that you've got like a client role, a Golang role, a manager role, a node role, a SOCAT proxy service role, a configuration file, and you can build it out really fast and get an actually just really strong automated process of deploying your tool. And yeah, that's how you do it with Ansible. There's been a bunch of Ansible presentations you can look back on how best exactly to write it. But it's very important that you remember that if you're running things like shell commands with your Ansible, it's not the same across all distributions. Like if you're on Debian, you're gonna have systemctl, but if you're on FreeBSD, you're gonna be using service. And then Debian, you have like apt install versus FreeBSD, you're gonna have pkg. And just things like that, it's important to remember the nuances between different distributions, not only when you're writing your tool, but also when you're writing your Ansible. Because in my Ansible, I have things that run shell scripts, and they might not always work. So it's important to remember that just because your Ansible works on one machine does not guarantee that it's going to work on every single competition machine right off the bat. You have to gradually test more and more deployments, and you have to gradually see whether or not it's actually working on different operating systems. And I cannot stress enough how important it is to test your tool. An untested tool, if it breaks during competition, is going to cause you a lot of headaches, especially if you don't know why it broke. And so please, if you're making your tool, just keep on testing it.
Yeah, so in conclusion, using alternative languages for making malware is an easy way to get into tool development or make your development process a little simpler. This is not a replacement for knowing low-level programming, but it's still good to have. It's like still, I mean, it is a good skill to have in this field of security, but it can be a great way to ease into it. Deployment is a crucial consideration when it comes to creating a tool. You should test your deployment a lot. You should focus a lot on the deployment process. And not only will your tool always work as intended, but those after you will be able to maintain it and use it for the future. And make a red team tool. It's a great way to learn. It looks good on a resume. It's a lot of fun to be on red team. Attend red team recruiting every Thursday at 8 p.m. Not every Thursday, not the next 2 weeks, but after that. And just talk to Drew. Get started. He'll give you some tool ideas. Everyone around the red team will give you some tool ideas. Any questions? No questions. Okay. Have a good day, guys.